Guys, let's look at this problem right here. This question is asking a flat thin film of material of defined refractive index and thickness lies on top of a liquid and is propped by an EM wave in the liquid. The other side of the film is exposed to air. What would be the minimum angle of incidence in radians that the incoming wave would need to have in order to enter the film but not pass through it? Okay, here the diagram for this question. And here you can see this is our entering angle, this is the incident angle, right? This is the question asking. The question is asking you to find out this angle right here. Let's call this one theta I1, and here we have the transmitted angle theta T1, and then here we are going to have incident angle 2, and this is going to be critical angle because the minimum angle in order to prevent from escape is going to be critical angle. At critical angle is going to be 90 degree, and more than that it's going to go total internal reflection, right? Total internal reflection. Since the question is asking for the minimum angle, we have to what would be the minimum angle of incidence. It means we have to find what is the angle of this one in order to have the critical angle. Okay, now let's go ahead and do this. First we are going to apply Snell's law for this part, the first part. Okay, Snell's law says Snell's law Snell's law says that sine n1 sine theta I1 is equal to n2 sine theta I2. Okay, now let's look at the index of refraction. The index of refraction of the liquid is given by 2.4. Okay, so this one is 2.4. So our n1 is equal to 2.4, and then index of refraction of this film is given by 1.7, and for the air is just 1. Okay, let's call this one n1, and this is n2, and this is n3. Okay, now we have this equation. Now let's look at the available values. We have n1 available, that is 2.4, and sine theta I1, we don't know the incident angle, that's the question, and then n2 is available, that is 1.7. okay, and then this should be theta 1, I mean T1. okay, because according to Snell's law, n1 incident angle 1 should be equal to n2 the transmitted angle 1. okay, so this would be theta 1, and this is going to be sine theta T1. okay, now I am going to rearrange this one in terms of sine theta T1. There's a reason for this, I will show, you will see later. So sine theta T1, and that's going to be equivalent to 2.4 over 1.7 times sine theta I1. okay, now this is, let's call this one equation 1. Okay, now we are going to apply Snell's law for this one. Okay, if we apply Snell's law again, let's call this is n2, right? So n2 sine theta I2 is equivalent to n3 sine theta C. This is critical angle because in order to prevent from escaping, we have to have the minimum angle should be critical angle, right? We have to have critical angle or total internal reflection. Since the question is asking minimum angle, it should be critical angle, so that's why theta C, critical angle. Now let's go ahead and plug the values. N2, we know that N2 value, that is N2 is equal to 1.7. 1.7 sine theta I2 is equal to N3 is going to be index of refraction of air, that's going to be just 1, and sine theta C, critical angle is always 90 degree, right? This is always 90 degree to the normal, so this is going to be just 90 degree. okay, now we have all this information available, and here we have to notice one more thing. Okay, so here we can notice one more thing, that is, if you look at this one right here, this part, this theta 1 is this angle, right? and this theta I2 is this angle. And if you look at this one carefully, you will see a Z shape. When you have Z shape and it's parallel, Z shape and it's parallel, it means this angle and this angle are equal to each other. Okay, this angle and this angle are equal to each other. Therefore we can say, instead of I2, I can write this one as 1.7 sine theta t1. Okay, this one is useful. It's useful to convert this one because we can plug this equation 1 instead of this theta 1, sine theta t1. We can plug this equation. Okay, so 1.7 sine theta t1 is equal to sine 90 degrees just 1, right? So this is going to be 1 times 1, that's going to be just 1, and then we are going to plug this one right here. This is going to be 1.7 times 2.4 over 1.7 times sine theta I1, that's equal to just 1. Okay, our question is asking us to find out theta I1, that's the main thing, right? So from this one we can solve for this, and also you can see 1.7 1.7 cancels each other. Finally we will end up with sine theta I1 is equal to 1 over 2.4, and if we rearrange this one in terms of theta I1, this is going to be sine inverse 1 over 2.4, and if you calculate this value you are going to get 0.4297, and if you round this one to 3 decimal places, that's going to be just 0.430, and that's going to be the angle in radians. Okay, and that's going to be the minimum incident angle we have to have in order to prevent this ray from going outside. And that's how we do this kind of problems. I hope this helps. Thanks for watching.